The next one is lag lead network. Lag lead network is the combination of lag and lead network components to improve both steady state and transient performance. So, in terms of frequency response analysis, what this lag lead network creates, we need to see. So, this network actually looks like this. Call this as R1 C1 for the convenience, and call this as R2 and C2, and this part is actually a lag network that creates a negative phase angle or phase lag, and this part actually creates lead. So, in this case, because of this arrangement, the time constant of lag part is greater than the time constant of the lead. So, tau lag is greater than tau lead. So, as both are involved here, the number of poles and zeros are 2 and 2 because lag and lead are combined. So, if you see the pole zero diagram of the lag and lead network. So, the lag is dominating here. So, the lag network consists of pole and 0, and the lead network consists of 0 and pole. So, this part is lag network. So, it is at minus 1 by alpha tau, minus 1 by tau. So, this is for lag. Now, here this is at 1 by tau lead, and this is at minus 1 by alpha tau. So, this part is for the lead network and this part is the lag network. But because of the dominant pole that is closer to the origin, the Bode plot, if you look at the Bode plot of the lag and lead network, and this is the magnitude plot in decibels and frequency on log scale, and this is the phase angle plot. This will be the phase plot. So, in the low frequency region, the lag network is in the picture, and high frequency region, the lead network is in the picture. So, you can actually see that the lag network, so this part of the response, you have a maximum phase lag in the low frequency region. So, the lag network dominates, and here you have the phase lead maximum. This is the lead network part. So, we can say that this part of the magnitude plot, from this I can say that this is a band stop filter. between these two frequency region. So this is 1 by alpha 2 tau 2, 1 by tau 2, this is 1 by tau 1, 1 by alpha 1 tau 1. That means here we have considered two parts of networks. So you have tau 1 given by C1 R1 for the lead network, and tau 2 is for the lag network, it is given by C2 and R2, and the time alpha constants, alpha 1 is the constant involved in lead network, as you know that this is given by R2 by R1 plus R2, this is less than 1, and alpha 2 is the lag network, and that alpha 2 value is greater than 1. So these four parameters will decide this band stop filter region. So lag lead network is nothing but a band stop filter. So the space of the band or the width of the band is decided by all these parameters. We call them as corner frequencies. We call them as corner frequencies. So there are four corner frequencies for lag lead network, and lag lead network is nothing but a band stop filter.